Well, hello students. Welcome to my Chapter 6 discussion on the time value of money. I'm presenting to you my teaching notes to use in company with the Spiceland Chapter 6 from the 7th edition. These notes are meant to be a supplement to the information, and page numbers are given along the way as we cover the different topics so that you can first read what I have to say, watch this video, and then go to the book and read that information as well. The book doesn't cover it in as much depth as I like to, nor does it have as much of an accounting emphasis. So by doing this, we'll get to add the things we think it needs. In this short video, I would like to cover the introduction and simple versus compound interest. So let's get started. Our first topic is simple interest. It's covered in the book on page 322 and 323. The formula for simple interest is to calculate the interest. You would take principal times the interest rate times the time. I would like to begin our discussion by looking at an example where we have an initial deposit of $1,000 and the interest is earned and paid at the end of each year for 4 years. And I'd like to calculate how much that would grow to be with you. So our initial deposit is $1,000. At the end of year 1, on simple interest, we take our $1,000 and times it by 10%, which gives us $100 of interest, and our new balance is $1,100. At the end of year 2, we still take the $1,000 because it's simple interest, times it by 10%, and add another $100 to the account. I would now like you to put this on pause and finish how much this will grow to be if left in an account for 2 more years and interest deposited at the end. Welcome back. How did you do? The end of year 3, you still earn another $100 of interest, so it's now $1,300. At the end of year 4, you've earned another 10% on your initial deposit, so your value has grown to $1,400. This is an example of how you compound interest using simple interest calculations. Let's now complete an example where you do the same problem using compound interest calculations. You make your initial deposit. It's $1,000 at the beginning of year 1. At the end of year 1, you earn interest at 10% on that, so it's $100, and your amount grows to be $1,100. At the end of year 2, you take the $1,100, the initial deposit plus interest earned to date. That's how compounding interest works. Grow it by another 10%, and it grows by $110. So your balance at the end of the second year is $1,210. Do me a favor and put this on pause and finish this table. How did you do? At the end of year 3, you had $1,210 deposited for the whole year, and it grew by $121, 10% of that amount, and it's now $1,331. That was invested for the whole year, and at the end of year 4, it grew by 10%, or $133, and it's now grown to be $1,464. So you can see with simple interest versus compound interest how this changes the accumulation. So, which one has a higher ending amount and why? Well, you will accumulate more interest when using compound interest techniques because interest is paid on the principal plus interest along the way. Let's take this a step further now and see how our example would change if you compound interest semi-annually, meaning twice a year. The first thing we need to do is take the 10% interest rate and cut it in half to 5%. Since we're doing it twice a year, we'll get 5% 2 different times. I'm going to do this example for only the first 2 years, but that will make up 4 lines or 24 months because it's twice a year. You make your initial deposit of $1,000. At the end of 6 months, you calculate interest on that. 1,000 at 5% gives you $1,050. At the end of 12 months, you take the 1,050 and times it by interest of 5% again, and interest is $5,250. Add that on, and your new balance at the end of the first year is $1,102.50. Take that out 6 more months, and at the end of 18 months, $1,102.50 grown by 5%, which is $55.13, becomes the $1,157.63. Please put this on pause and finish the last row. At the end of 24 months, it has grown to be $1,215.51. So, when you compare this with the second year for the compound interest table above, which one has the higher balance and why? At the end of 12 months, when compounding semi-annually, we have $1,215.51. If we scroll back up and we look at our balance in the compounding interest when you do it annually, at the end of year 2, there's only 1,210 in the account. And again, it would be at the end of the second year that we're doing the comparison. So you could say that the one that compounds twice a year has a higher balance, and draw the conclusion that compounding more frequently increases the effective rate of interest. Isn't that interesting? That was funny. So, solving time value of money problems is fun. It's interesting. I'm so cute. Time value of money problems can be solved in several different ways. One is by hand, using that successive interest computation we did above, where we make a fund accumulation schedule showing how the fund is growing. Another is by mathematical formula, which I'm not going to use with you. We have calculators for that. And third's by using the interest tables that are found in your book. We'll be using those regularly. And a fourth way is by calculating with the time value of money functions calculator. I recommend the Texas Interest Business Analyst 2 or Business Analyst Plus. It's a good, inexpensive calculator. And again, for the most part, we'll be focusing on 2 methods and sometimes 3. We'll always do the calculate by using the interest table and the time value of money. But occasionally we'll also use a successive interest computation. You should get your calculator now and start learning how to use it. You'll use it in all of your accounting classes, and you are responsible for learning how to make it work. Make sure you get the instructions. I think you have to download them. The charts that I mentioned above are found in the book, at the back of your book, and I also have copies of them available for you in Connect in the library. Go to Connect, click on Library, click on your files, and you'll find the present value tables there. You should print them, and you should have them handy for the remainder of intermediate accounting. From now on, present value questions are fair game on all tests. There's one more thing I want to show you that the book doesn't really go into, and that's how to convert annual interest rates, because the table assumes constant interest periods, and you're usually given interest rates in annual terms, but sometimes the problem asks for semi-annual or quarterly or even monthly compounding. When that's the case, you need to be able to adjust the interest rate for the period and the time period for the compounding periods that we're going to use. Let's take an example and work through it. Let's say you have a 12% interest rate for 5 years. I equals 12 and N equals 5 if you are doing it annually. I being the interest rate and N being the period of time. First, let's tackle semi-annually. If you're going to compute interest semi-annually, you would need to divide the 12 by 2 because you're doing it twice a year, and that would equal an interest rate of 6. Well, if you have 5 years and you're doing it twice a year, then you would end up doing it 10 times. So let's compare annual to semi-annual. Annually, you would use a 12% interest rate and 5 periods. Semi-annually, you would use a 6% interest rate and 10 periods. How do you think that would work out quarterly? Well, if you're taking 12% and doing it 4 times a year, divide by 4, and that would be I equals 3. And if you're going to do it 4 times a year for 5 years, you'll end up having an N equals 20. That would be adjusting an annual rate of 12% for 5 years to quarterly compounding. Now you finish the table for monthly. Welcome back. How'd you do? If you're going to have a 12% interest rate for 5 years, your interest factor, would equal 1%, and your number of periods would be 60 to show monthly compounding. Why is it important? Why do you need to know an I, or an interest rate, and an N, a number of periods? I've taken a screenshot of Table 1 from your book, and I want you to notice that the N is in the first column, and you find the number of periods you're looking at. In our first example, we had 5 years, so if you're doing it annually, you would come to this row, number 5. So you find your N in this first column. When you're looking for an interest rate, you read across the row until you come to 12%. In our case, if we were using 12%, we would come to this column. The intercept of I equals 12 and N equals 5 would be right here. Number of periods is 5 and intercept is 12. You need to be able to do that because we'll be doing that many times in later chapters of the book. There are 6 tables that we'll use in this book. They're in the back of the book, and they're also on Connect again. And we'll do most of our problem solving with a time value money calculator and these interest tables. It's nice because you can get the interest table number and the time value of money number and actually know for certain that the number you've picked is correct on a test. We'll use table 1 where we look at the future value of $1, and in our case we looked at what $1, the present value of it, would grow to be over N equals 4 and I equals 10. Table 2 is the opposite. It says you know the future value. How do you get that back to the present? So when looking for the present value, take the future value and look for an interest factor from table 2, which is a present value interest factor where you know an N, a number of periods, and I, in interest rates. Table 3 is a future value with an annuity. An annuity means a payment. Table 4 is the present value of an annuity. Table 5 is the future value of an annuity due. And table 6 is the present value of an annuity due. I'm sure that these don't mean too much to you right now, but they will shortly. As we make our way through the book, you'll become an expert at these. I'm excited to work with you on these concepts, and I hope you find it entertaining, and here it comes. Interesting. This concludes my first discussion on the time value of money. Thank you for joining me. Now would be a good time to go back and read those pages in your book, pages 322 to 323. Your author pulled it off in a short number of pages, didn't he? Well, we'll talk to you soon.